All right, guys, yesterday, again, we did that little activity at the end with exponents for us and just kind of reintroducing ourselves to the difference between what it means to multiply two numbers and what it means for that number to be an exponent. So today we're going to look at simplifying a little bit using exponents and then just refreshing on what that exponent means, okay? So if we take a look at example number 1, should be up at the top of your sheet. If we take a look at example number 1, what can I do if I have these three negative 2's written right next to each other? What does it mean if we have those numbers written right next to each other with parentheses? What operation are we looking at?
Multiplying.
We're looking at multiplying. Well, it's kind of a pain in the calculator if I have to enter in all those parentheses and all those negative 2's. Is there a simpler way we could do that? Chase, what do you think?
Negative 2 times 3.
So negative 2 times 3, we saw that yesterday. Is that going to get us the same as negative 2 times negative 2 times negative 2? What do we have to do to it, John?
We have to put a negative 2 with an exponent of 3.
Negative 2. And then how many negative 2's am I multiplying together?
3.
3. That's going to become my exponent. Remember, we saw yesterday if we did 2 times 3, we would get 6. But if we put 2 to the third in our calculator, we're going to get 8. So that's going to simplify that piece for us. Times, I don't want to have to mess around with 3 times 3 times 3 times 3. So how can I simplify that piece? What do we think, Sam?
I think we got to do this. We got to do 4, and then another one is 3.
So we're going to have a 3. Then how many 3's am I multiplying together? To the power of? 4.
That's what I'm saying.
So if we're multiplying the same number together time after time after time, instead of having to do negative 2 times negative 2 times negative 2, we can simplify that down. We can have negative 2 to the third power. Your exponent piece is going to tell you how many times we need to multiply that. It's going to tell us how many times we need to multiply it. Let's take a look at our second one. Our second one looks a little different. In order to use exponents, we have to be multiplying. So I see a lot of multiplication in the second one. But unlike the first one, I see a lot of, I have a 1/2 here, and a 1/2 here, and a 1/2 here, and a 1/2 here. We're multiplying. I don't know if you guys have ever really named some of the properties you can use when you multiply, but there's a property in multiplication called the commutative property. I won't ever test you on the names of those properties, but there's a commutative property that tells us I can multiply things in any order I want. So that entire second question is all multiplication. So I can rearrange that however I want. So I can do this. I can put all of those 1/2s, all 4 of them. I can put all 4 of them right next to each other. And I can put the 3a's right next to each other too. With multiplication or addition, you can multiply or add in any order that you want. So I can put all those 1/2s together, and I can put all those a's together too. Now, I know that in a calculator, a fraction especially can be really hard to enter. So I don't want to have to keep doing a 1/2 times a 1/2 times a 1/2 times a 1/2. Let's use our exponents and let's simplify some things. How many 1/2s am I multiplying together? How many do I have there, Sam?
4.
I have 4 of them. So the 1/2 that I'm multiplying together is going to be it's called your base. It's going to be my base. What's my exponent going to be? What's the exponent going to be? What's it going to be, Sam?
4.
It's going to be
2 and 2.5 and a 4.
So we're going to have 1/2, and my exponent is going to be a 4.
That makes sense a little bit.
So the number that I'm multiplying repeatedly, so the 1/2, 1/2, 1/2, 1/2, that number becomes my base, or some people like to say, hey, Miss Golly, that's the big number, right? Yep, that's the big number. And then the exponent is how many times I'm multiplying that number together. So I have 4 1/2, so the exponent, some people call it the little number, that's my 4. I also have some A's. I have some A's there.
Yeah, I like that part. Yeah, I like it.
So the thing that I'm multiplying together is A. A times A times A. So whatever I'm multiplying repeatedly becomes my base. Oh, we're going to do a little multiplication symbol in there. The thing that I'm multiplying over and over and over becomes my base. How many times I'm multiplying it becomes my exponent. So I'm multiplying it 3 times. So the number or the variable that I'm multiplying together is my base. That's the big number. The base is my big number. How many times I'm multiplying it? That's my exponent. So 1/2, 1/2, 1/2. The number I'm multiplying is my base. I see that up there 4 times, so the 4 becomes my exponent. So whatever you're multiplying together is your base or the big number. However many times you're multiplying it, that becomes your little exponent. Let's try the other one. Let's look at that second box of examples. And let's try the other way. Now I know it says evaluate, so yep, we could just pop that right in our calculator. And that's something we did yesterday. What I want to do first is let's expand this. Let's expand this out. I want to make sure that we really, really understand what those exponents mean. I know we scratched the surface yesterday. We entered some things in the calculator, and we saw that 4 times 4 is different than 4 to the 4th. We saw that. But I want to make sure today we really know what's going on in that calculator when we put something like 4 to the 4th in. So what we saw up above, that big number, that base number, that's the thing we're multiplying together. The exponent tells us how many times to multiply it. So the number I'm multiplying together is 4. How many times I'm going to do that is also 4. How many times I'm going to do that is also 4. I want to expand these out, and then I want to do what we did yesterday. I want us to make sure in the calculators we know how to enter those ones that have the parentheses and the ones that have fractions. So I do want to go through that today as well with you. But I want to expand these out first. I really want to make sure that in this section we really understand what it means to have that exponent. Not just, well, I popped it in my calculator and I got a different number. All right, let's check out number 2. Let's check out number 2. The number I'm actually going to multiply is that base. It's the big number. That's the number I'm actually multiplying. The little number, that exponent, tells me how many times I'm going to multiply it. So the number I'm multiplying is the big one, -2. How many times I'm going to multiply it is the exponent. So I'm going to multiply that 6 times. And I know, like, oh, Miss Kelly, writing out 6 times, that's a lot of work. But guys, I need to make sure that we really know what is going on with that exponent. Not just, yep, I know how to put my calculator, I'm good now. I want to make sure we really know what an exponent means, what it does. I want to give you guys a chance to try out that third one. Again, right now, I don't care what 4 to the 4th power equals. I want us to focus on right now what it means. And then we will take a look using the calculator how we enter these things in and make sure we're solid there. Okay, I want to make sure we're solid there. So try out number 3. Try expanding it out for me. All right, as I walked around, it was pretty unanimous. I saw 1/5 times 1/5 times 1/5. Whether you use parentheses or I also saw people putting the dot, that is wonderful too. So the 1/5 is our base. That's the big number. We're going to multiply that one together. The exponent of 3 tells me how many times to do that. Notice not a single time up here, guys, when it was 4 to the 4th, I did not do 4 times 4. It was 4 times 4 times 4 times 4. Like we saw in our activity yesterday, that's a different thing. 4 times 4 and 4 to the 4th, 2 very different things. -2 to the 6th, I didn't do -2 times 6. I did -2 times itself 6 times. So notice the difference. I just wanted to hit that home again today. So let's go ahead and let's make sure we can all enter these into our calculators. Let's make sure we can all enter them in. So if you think you know how, go ahead and play around with it. And then let's see what we come up with. If you're unsure how, let me know and I will come around and help you out. And actually, I'll probably put it up on the Elmo real quick too. All right, so we found out, what was this first one, guys? What was the first one? 256. Then we had 64 and 125th, right? Okay, just want to make sure I got those filled in up here. I know you guys all had them on your papers. All right, now the evaluate piece. Now we're given an expression that just has variable bases. But then off to the side, we're told, hey, here's what you need to put in for those bases. Here's what you need to put in. So anywhere, so number 4, anywhere I see an A in that expression, if A equals 3, that means wherever I see an A, what can I put in its place? What can I put there instead of A? What can I put? Yeah, 3. I can put a 3 there. If 2 things are equal, it means they're interchangeable. So wherever I see that A, and general rule of thumb, it's called substituting. Whenever you substitute in, we should use parentheses. Whenever you substitute in. I just want us to get in that habit. And then we have a B. Well, I can't put B to the 4th power in my calculator. I can't evaluate that. So where I have a B, I can always replace it with a 5. If B equals 5, that means wherever I see a B, I can replace it with a 5. I can substitute a 5. Now you can practice with the calculator, guys. You can type all that in at once. You can type all that in at once in your calculator. So go ahead and evaluate that piece. And also try out number 5. So for number 4, we should get 634. If you got that, go ahead and try number 5. Number 5, guys, as I walk around, number 5 is looking really, really good. Number 5 is looking good. Wherever I see a C, that's kind of funny to say. Wherever I see a C, I get to put -4. And wherever I see a D, I can put a 9 in its place. What did you guys come up with when you put that in your calculator? Colin, what'd you come up with? 17. If you didn't come up with 17, guys, be very careful. Make sure that you did put a negative for your 4. I saw a couple different answers as I walked around. And not putting a negative with that 4 can throw it off big time for you. Okay? All right, what I want us to do, guys, that's the end of our little lesson piece. All right, guys, so we have our examples there. You can use your notes. This is the assignment piece that I just handed out. I want to make sure we understand the directions, though. Before we just dig in and all of a sudden you throw everything in your calculator and boom, Miss Golly, I'm done. Nope. We shouldn't be using calculator until we get to the bottom part. So when it says expanded form, example of that would be 3 to the 4th power equals 3 times 3 times 3 times 3. That's expanded form. It does not mean I put 23 to the 7th power in my calculator and it spits me out this giant number. The expanded form is showing me, do you know what exponents mean? Okay. When it says to rewrite in exponent form, that's when we take 3 times 3 times 3 times 3 times 3, and we rewrite it as 3 to the 5th. Again, nothing in my calculator. I haven't touched the calculator yet for any of those top 8 questions. The top 8 questions are all about practicing and make sure we know what that exponent means, what it does. Now, when you get to the bottom, and we're talking standard form, now we're talking calculator. Type in 2 to the 4th power and get the result of 16. I will leave my notes up there on the board for you as you're working. Let's see if we can get this finished up today. We might even be able to get it checked because I think especially that bottom part's going to go really, really fast for you. But we'll see where we're at. Let's not rush it. If we correct it Tuesday, we correct it Tuesday. Let's see how we do.